Imagine staring at a photo from Mars and seeing what looks like a fragment of coral, the kind you'd expect to find in a tropical reef, not on a barren, frozen desert millions of kilometers away. That's exactly what NASA's Curiosity rover recently sent back, an image of a pale, branch-like formation standing out starkly against the red dust of Gale Crater. Of course, it's not living coral. What Curiosity found is a small rock, only about an inch across, sculpted by the Martian environment over unimaginable spans of time. Billions of years ago, Mars wasn't the dry, frigid planet we know today. It had flowing water, streams, lakes, maybe even shallow seas. That ancient water carried dissolved minerals, seeping into cracks and fissures in the bedrock. Over time, those minerals crystallized, forming solid veins within the rock. As eons passed, fierce winds whipped through the crater, sandblasting the softer stone away and leaving behind these intricate, coral-like shapes. The rover's telescopic camera, the Remote Micro Imager, captured the black and white photograph in late July. The details are striking. Fine branches curling and splitting, almost as if frozen in mid-growth. It's the kind of image that makes you blink and look twice, wondering how something so familiar could form in a place so alien. Curiosity has spotted similar oddities before. Back in 2022, it photographed a tiny flower-shaped mineral growth in the same crater. Just this past July, it also discovered a strangely shaped rock, dubbed Poposo, about twice the size of the coral-like specimen. These formations, while beautiful, are more than geological curiosities. They're clues to the red planet's watery past. When scientists examine features like this, they're not just admiring nature's artistry. Each vein of mineral, each unusual erosion pattern, tells part of a much larger story. Mars once had the right conditions for life. The planet's surface holds chemical signatures, like long chains of carbon molecules, dating back 3.7 billion years. These aren't proof of past life, but they hint that Mars had a functioning carbon cycle, a crucial ingredient for biology as we know it. Curiosity's mission is built on following such clues. Since its landing in 2012, the rover has slowly made its way across Gale Crater, covering about 22 miles in more than a decade. Its route is deliberate, with frequent stops to drill into rocks, analyze samples, and study the surrounding terrain. Every discovery, whether a microscopic mineral bloom or a vast sediment layer, adds a new piece to the puzzle of Mars's history. Gale Crater itself is a prime location for this detective work. It's a massive impact basin, 96 miles wide, with a layered central mountain that preserves billions of years of geological history. The lower slopes contain clay-rich rocks which form in the presence of water. Higher up, the layers transition to sulfate-bearing rocks, marking the shift to a drier climate. By climbing this sequence, Curiosity is essentially traveling through Mars's environmental timeline. The coral-shaped rock is a snapshot from that timeline, a remnant of a time when water trickled through cracks and deposited minerals. Much like groundwater on Earth can form quartz veins. The fact that such delicate structures have survived speaks to the slow, persistent forces that shape Mars today: wind, dust, and time. It's easy to see why images like this ignite the imagination. They blur the line between alien and the familiar. If something so Earth-like can emerge on Mars without life, it challenges us to rethink what signs of life might look like elsewhere. Would we even recognize them? Or could we mistake them for geology, just as someone might mistake this little rock for coral? The discovery doesn't mean there are coral reefs buried under the Martian surface, but it does mean that Mars once had the chemistry and conditions to create complex, beautiful structures through natural processes alone. For scientists, that's just as exciting, because it means the planet was dynamic, a world with cycles, fluids, and chemistry at play. Curiosity keeps pushing forward, methodically studying the landscape, each image and sample adding to a growing archive of evidence. And every so often, it sends back something like this: a small, unassuming rock that sparks wonder, questions, and a reminder that even in the cold emptiness of another world, nature still finds a way to surprise us.
Imagine this. A sleek spacecraft lands back on Earth, carrying with it tiny pieces of rock and dust from the surface of Mars. Inside those rocks, frozen in time, could be the greatest discovery in human history, or the biggest threat. We've seen it all before in sci-fi. Aliens hiding in plain sight, taking over our bodies, our minds, our world. From the eerie replacement of humans in Invasion of the Biosignatures to the grotesque shapeshifter of The Thing, fiction loves to terrify us with stories of life from beyond. But let's be honest, nobody really believes an alien's gonna crawl out of a pod and eat your face. But what if the real threat isn't something big and monstrous? What if it's microscopic, silent, invisible, and real? In the next decade, humanity is planning something extraordinary. A mission to Mars will not just explore, it will bring pieces of the red planet back home. NASA and ESA are already preparing for the Mars sample return mission. It sounds like a huge leap forward in space exploration, and it is. But with it comes a question that scientists are only beginning to wrestle with. What if something is alive in those samples? And no, we're not talking about Martian octopuses or intelligent civilizations. We're talking about microbes, bacteria-like organisms that could have survived for millions, even billions of years beneath the Martian surface. If they exist, and if we're not careful, they could interact with our biosphere in unpredictable ways. That's why scientists around the world are racing against the clock to figure out how to detect life in Martian rocks without destroying the precious material in the process. Because here's the catch. Once we bring Mars samples back to Earth, we won't get a second shot. These fragments of another world are irreplaceable. Enter Yohei Suzuki, an associate professor at the University of Tokyo, and his team. They've developed a cutting-edge method that could change everything. It's called optical photothermal infrared spectroscopy, or OPTIR for short, and it can detect signs of microbial life in rock samples without grinding them into dust. Let's break this down. Traditional methods, like electron microscopy or nanosims, can reveal microscopic life, but they usually destroy the sample in the process. Not ideal when you're working with a rock that traveled 300 million kilometers to get here. OPTIR, on the other hand, only requires a thin slice of the sample, about 100 micrometers thick, and leaves the rest untouched. It's like giving a biopsy to a rock without killing the patient. What's more, the resolution of this technique is insanely precise, down to 0.5 microns. That's small enough to detect microbial cells and even distinguish between different types of biological molecules, like proteins. In tests using Earth rocks that are 100 million years old, Suzuki's team was able to identify microbial life still locked inside clay-filled fractures. These aren't just guesses or blurry images. The spectral fingerprints they captured, patterns of light and heat, match known biological signatures. It's like finding a fossil, but on a molecular level. But wait, it gets even better. The rocks they used as Martian analogs weren't chosen at random. They specifically selected basalt, a type of volcanic rock common on both Earth and Mars. In fact, the Perseverance rover has already collected basalt samples from the Jezero crater, and those are the very samples expected to return to Earth. Suzuki and his team are essentially rehearsing with Earth stand-ins before the real show begins. So what does this mean for us? It means we're on the brink of possibly answering one of the most profound questions in human history. Are we alone in the universe? Are we alone in the universe? Are we alone in the universe? But it also means we have to proceed with incredible caution. The organization overseeing planetary protection, COSPAR, has classified this as a Category 5 Restricted Earth Return mission. That's as serious as it gets. It means that the samples must be sealed, sterilized if needed, and analyzed using only the most advanced, non-destructive techniques available. The goal? To reduce the risk of accidentally releasing an alien microbe into Earth's environment to 1 in a million. That's right, scientists are literally working to make sure that the odds of missing a living organism, if it's in there, are less than 1 in a million. So while the movies like to show aliens crashing into Earth in a ball of fire, the real invasion, if it happens, might arrive in a test tube under tight quarantine, escorted by men in hazmat suits. And yet, that test tube could hold the answer to everything. Life on Mars. A second Genesis. Proof that Earth isn't the only cradle of biology in the cosmos. For now, it's a waiting game. Scientists continue to refine their instruments. Engineers prepare the containment systems. And somewhere, millions of kilometers away, little pieces of Mars are waiting to come home. And when they do, we'll be ready. We hope.
Mars has long been a source of mystery and fascination, with numerous anomalies discovered on its surface that challenge conventional explanations. Among the most intriguing is a square-shaped formation captured by the Mars Global Surveyor's orbiter camera. This unusual structure, visible in an image available through Arizona State University's Mars Image Explorer, has sparked intense debate among researchers and enthusiasts alike. Many believe that this geometric formation, along with other peculiar structures on Mars, warrants further investigation as it could potentially reveal artificial or unknown processes shaping the Martian landscape. The discovery of this square-shaped formation has raised profound questions about its origin. Unlike the chaotic natural formations typically seen on Mars, this structure exhibits a level of symmetry and geometric precision rarely found in nature. Most natural geological processes, such as erosion and volcanic activity, tend to create irregular, unpredictable formations. However, the almost perfect angles and well-defined edges of this Martian square suggest that it may not be the product of ordinary geological forces. Some skeptics argue that its unique shape indicates an artificial or intelligently designed origin, pointing to the possibility that Mars may have once harbored an advanced civilization or been visited by extraterrestrial beings in the distant past. If this theory holds, the square formation could represent the remnants of an ancient structure, now partially buried under Martian dust and sediment. One of the most compelling aspects of this formation is its location and scale. The image from the Mars Global Surveyor provides detailed measurements suggesting that the square formation is significantly large, far beyond the scale of ordinary rock formations. Its distinct shape compared to the surrounding terrain makes it stand out as an anomaly, further adding to the mystery of its existence. If it were merely the result of natural geological processes, one would expect to see other similarly shaped formations nearby. Yet this is not the case. This discrepancy raises questions about whether Mars has undergone processes unknown to mainstream science, or if intelligent intervention played a role in shaping its surface. Supporters of the artificial structure hypothesis argue that the square formation could be a remnant of an ancient Martian civilization, similar to the ruins of ancient cities found on Earth. They suggest that if Mars once had conditions capable of supporting life, it is entirely plausible that an advanced society could have flourished there before some catastrophic event led to its demise. Given the evidence of past water activity and the possibility of an ancient atmosphere, this theory is not as far-fetched as it might seem. If Mars did indeed host intelligent life in the distant past, structures like the square formation could be key to understanding the history of the planet and the fate of its inhabitants. Another possibility is that the square formation may be linked to extraterrestrial visitors. Some researchers speculate that Mars may have been used as a base or an outpost by non-human intelligences at some point in history. The precision of the square shape and its distinct edges lend credibility to the idea that it may have been deliberately constructed rather than formed through random geological processes. If true, this would suggest that Mars has played a far more significant role in interstellar history than previously thought. NASA and other space agencies have largely remained silent on the implications of these formations, often dismissing them as natural rock formations or imaging artifacts. However, this stance has not deterred independent researchers and analysts from continuing to investigate. With the increasing availability of high-resolution images from Mars rovers and orbiters, more anomalies are being identified. adding to the growing body of evidence suggesting Mars may not be the barren, lifeless world it is often portrayed to be. The presence of geometric formations on Mars raises profound questions about our understanding of planetary science and history. If the square formation is indeed artificial, it could revolutionize our understanding of Mars and the possibility of extraterrestrial intelligence. Despite skepticism from mainstream scientific circles, the demand for further study of these formations continues to grow. Many argue that future missions to Mars should prioritize the exploration of these anomalies using advanced technology to determine whether they are truly artificial in nature. With human missions to Mars on the horizon, the opportunity to investigate these structures up close may soon become a reality. If we are to uncover the true nature of Mars, we must be open to the possibility that what we find there could change everything we thought we knew about the universe. The square-shaped formation on Mars remains one of the most intriguing and unexplained discoveries in planetary exploration. Its geometric precision and distinct appearance challenge traditional explanations and fuel speculation about its possible artificial origins. Whether it is evidence of an ancient civilization, a remnant of extraterrestrial visitors, or a geological anomaly unlike any seen before, this formation demands further study. As humanity continues to explore the cosmos, we may one day uncover the truth about Mars and the mysterious structures that lie on its surface, revealing secrets that have been hidden for millennia.
A giant volcano has been found near Mars's equator. It was literally hiding in plain sight. It's deeply eroded but active from ancient to recent times. There might even be remnants of glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The discovery of a giant volcano and a possible sheet of hidden glacier ice was announced at the 55th Lunar and Planetary Science Conference in Texas. The volcano is located in the eastern part of Mars' Tharsis volcanic province, between Labyrinth of the Night and Valleys of Mariner. The formation was actually repeatedly spotted by spacecraft orbiting Mars, but it's so deeply eroded that it was hard to recognize it for what it really was. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin recent volcanic deposit, and beneath, glacier ice might still be present. Scientists were examining the geology of the area where they had spotted the remains of a glacier the year before when they realized they were inside a volcano. Several clues gave away the volcanic origin of the eroded structure. For example, the area of the central summit has a few elevated mesas forming an arc. It reaches the highest point and then slopes downhill from the summit. The outer slopes extend out to 140 miles in different directions. The remains of a collapsed volcanic crater that used to host a lava lake are located near the center of the structure. Lava flows and deposits made of volcanic ash, cinders, pumice, and rock fragments ejected during eruptions, as well as hydrated mineral deposits, appear in several spots within the structure. In addition to the volcano, a large area of volcanic deposits within the volcano's perimeter has been found, too. It covers an area of 1,930 square miles and contains loads of low, rounded, elongated, blister-like mounds. Such terrain is believed to be a field of rootless cones, mounds produced by explosive steam venting or steam swelling. It happens when a thick cover of hot volcanic materials happens to rest on a water or ice-rich surface. The Noctis volcano seems to have a long and complicated history of modifications. They might have occurred because of the combination of fracturing and thermal and glacial erosion. Researchers believe the volcano could be a vast shield made of layers of pyroclastic materials, lava, and ice. The latter might have appeared due to snow and glaciers accumulating on the volcano's flanks through time. Eventually, fractures and faults developed in the region, probably due to the uplift of the Tharsis region on which the volcano sits. Lava started to rise through various parts of the volcano, It led to thermal erosion and the removal of huge amounts of hidden ice. Entire sections of the volcano collapsed. Glaciers continued the erosion process, giving the numerous canyons crisscrossing the structure their peculiar shape. If this version is correct, then possible hidden sheets of glacier ice around the volcano might be the remains of the latest glaciation that impacted the Noctis volcano. And still, a lot about the newly discovered formation remains a mystery. It's obvious that it has been active for a long time and started to grow early in Mars's history, but it's unclear when exactly. Even though it erupted even in modern times, it's unknown if it's still volcanically active. Will it erupt again when people begin to colonize the red planet? And finally, if it has been active for a very long time, is it possible for the combination of constant warmth and water from ice to allow the site to harbor life?
There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the red planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
It looks like a regular beach, but something sets off an alarm blaring in your head. The sand looks too red, the sun is too bright, the wind is all wrong, it's hard to breathe, and there's no water in the ocean. Well, panic not, it's normal, since you're on Mars. For the longest time, we've seen Mars as a dry, lifeless dust ball, a freezing desert where water exists only as ice or vapor. But new research suggests that billions of years ago, it was a totally different place. And instead of endless dust, it may have had something much more familiar to us – sunny, sandy beaches. Scientists from Penn State, UC Berkeley, and Guangzhou University studied radar data from China's Zhurong rover. It started to roll across Mars in 2021. While exploring the surface of the red planet, it found sloping rock formations that looked strikingly similar to the ones found on Earth's coastlines. Those are called foreshore deposits. They form when waves push sand onto a shoreline. But Zhurong wasn't just taking pretty pictures. It also had ground-penetrating radar, a tool that allowed it to scan deep below the Martian surface as it traveled 1.2 miles between May 2021 and May 2022. And it found something pretty wild. Layers of sediment sloping down at a 15-degree angle. This pattern is identical to the ones left behind by waves on Earth. And this wasn't from the wind, volcanoes, or anything else. It just looked like a real beach. And that's actually a big deal. Because if there were waves and tides, there must have been a large body of water. That means Mars may have once had just the right conditions for hosting life. Even after 3.5 billion years, the formations are still incredibly similar to beaches on Earth. So there must have been a time when Mars was much more than just a dusty rock in space. After revealing this shocking news, Zhurong's radar scanned 260 feet deep into the ground, discovering sediment layers. They once formed along a path perpendicular to an ancient shoreline, the one that likely existed 4 billion years ago. At the same time, it might not be all that surprising. Back then, Mars wasn't the dry, frozen wasteland we see today. It had a thicker atmosphere, a warmer climate, and plenty of liquid water. And I'm not even talking about some tiny puddle. Beaches don't form without a massive body of water. For wave to shape the land like this, there had to be rivers flowing into a vast ocean. Powerful currents had to be moving sand around, and water had to stick around for a long time. This couldn't be just a brief wet spell. It was a period where Mars was hydrologically active for millions of years, potentially being a place where life could have thrived. This discovery gives even more weight to one theory. It has been puzzling scientists since the 1970s. That's when NASA's Viking spacecraft snapped images of what looked like a shoreline wrapping around Mars's northern hemisphere. But there was a problem. The shoreline was all over the place, with elevations varying by up to 6 miles. Wow, which is nothing like our flat, mostly consistent shorelines we see on Earth. This difference made scientists doubt that a Martian ocean ever existed. For years, scientists have been trying to crack this mystery. In 2007, they suggested that Mars' rotation actually shifted billions of years ago. As the planet's massive Tharsis volcanic region grew, the planet's spin axis tilted, warping the surface. It could explain why the shoreline is so uneven today. In other words, what once was a flat and level landscape got distorted over time. Interestingly, Mars has been dropping hints about its watery past for years. Curiosity found ancient ripples in Gale Crater. There were signs of a long-gone lake. Perseverance is currently studying a fossilized river delta in Jezero Crater. Now, with Zhurong's evidence of an ancient ocean, it all comes together. Small lakes? Check. Rivers? Check. A massive ocean covering the northern lowlands? Quite possibly. Zhurong's mission wrapped up in May 2022 after dust blocked its solar panels, but future missions could still explore those ancient shoreline deposits. Scientists might send new missions to drill deeper into the ground to retrieve samples. Or we could use better radar to map Mars' subsurface in more detail. There's a real hope to excavate those areas in the future and find even more clues about Mars' past. At the same time, NASA's Perseverance rover is already working hard in Jezero Crater collecting samples. Scientists hope that it will bring them back to Earth in the 2030s. While those won't include samples from the ancient ocean, they could still help us find out more about Mars's wetter history. For now, the discovery of ancient beaches on Mars gives us a peek into a time when the planet might have looked a lot more like Earth, with water, waves, and rivers. Now let's speak about the Perseverance rover that's still working on Mars in more detail. It has a special drill on its arm and uses it to scrape off the dust and top layers of rock, making small 2-inch wide circles in Jezero Crater. Once, one of its cameras took a close-up photo, and the image showed that the rock wasn't smooth. It was made of tiny interlocking crystals. The rover used two special tools to analyze the rock's chemistry. The results confirmed that the rock, named Rochette, was volcanic. It meant it formed from lava or magma, not from mud and clay, like scientists had expected from a former lakebed. Perseverance, also known as Percy, landed on Mars in February 2021, along with a small helicopter named Ingenuity. It is the most advanced rover ever sent to Mars, following in the footsteps of Curiosity, Spirit, Opportunity, and others. But Percy has a different mission. While older rovers mainly studied Martian rocks and climate, Perseverance is searching for signs of past life. Scientists chose Jezero Crater because it looks like it used to be a lake where tiny life forms could have lived. The rover drills, scrapes, and collects rock samples to study with its science tools. It also saves some samples to bring back to Earth in the future for even closer study. Perseverance has found some surprising things on Mars. Scientists studying the data it sent back have discovered that Jezero Crater has changed a lot over time. Long ago, this area had flowing lava, a lake that lasted for thousands of years, rivers that carried mud and sand, and even massive floods that brought in rocks from far away. It means that Jezero's history is more active and unpredictable than scientists expected. This definitely made it harder to find the sedimentary rocks they were looking for. But it has also revealed new places where ancient life might have existed. Another exciting discovery is that every rock Perseverance has studied so far contains carbon-based materials, the same stuff that life on Earth is built from. NASA's Perseverance rover also carries a special tool called MOXIE, which has managed to make oxygen from the carbon dioxide in Mars' atmosphere for the first time. Over 16 test runs, MOXIE produced about 4 ounces of oxygen. That's enough to keep an astronaut breathing for about 4 hours. It worked even better than expected, making up to 0.42 ounces of oxygen per hour. After running successfully for 2 years, MOXIE completed its final test in September 2023. It brings us one step closer to sending humans to Mars in the future. In any case, back to the discovery of ancient shorelines on Mars. This finding might help us see the red planet with new eyes. Water might have been flowing across its surface for tens of millions of years, carving out lakes, rivers, and even a vast ocean. What else have we misunderstood? Did Martian dinos stroll across the vast green valleys of the planet? Or were those bizarre marine creatures the likes of which we can't even imagine? Well, we don't know yet, but one thing is very likely. Mars had an era of warmth, water, and maybe life.
You could get to Mars in just 30 days. No, this isn't sci-fi. A new, breakthrough plasma engine could actually make it happen. Pretty soon, we might be swapping our beach chairs in the Bahamas for a trip to the Red Planet. So, when can we buy our tickets? Well, probably not until 2030. And even then, those first rides will probably be a luxury reserved for astronauts, not tourists. They're already thrilled though, because this engine could change everything about space travel, cutting flight times way down and making missions a lot easier to handle. Right now, traveling to Mars is just a dream. Nobody's ever set foot there, and there's one big reason why. A round trip would mean spending years stuck in space. And that's anything but safe. We did send people to the moon though, but that's a whole different story. Getting to our natural satellite only takes a few days. The fastest trip was Apollo 8, when the crew made it from Earth's orbit to the moon's orbit in just under 3 days. If the team wants to save fuel, they might choose a different route to get there. And those paths can take way longer, sometimes weeks, even months before they finally reach the moon. So how long it takes to get there is more of a strategic choice. Now, what about Mars? Well, the Red Planet is a lot farther away. On average, it's about 140 million miles from Earth. According to NASA, even if you could hop on a spaceship right now and head straight there, the trip would take anywhere from 7 to 10 months. Take NASA's Mars Reconnaissance Orbiter, for example. This spacecraft launched from Cape Canaveral in August 2005. and didn't reach Mars's orbit until March of the next year. How long the trip takes can change though. That's because the distance between Earth and Mars is always changing as they orbit the Sun. So even if we can get there in a few months, a round trip could end up taking nearly 3 years. And nobody wants that. Not just because it'd be boring to live up there without Netflix, but because it's seriously risky. Spending that much time in space can do real damage to the human body. You see, a mission to Mars would put astronauts through 3 different gravity fields. First, during the trip to Mars, they'd be weightless. Then, once they arrive, they'd have to live and work in a gravity that's only about a third as strong as Earth's. And finally, when they come back, they'd have to readjust to Earth's gravity. Switching between all those gravity fields is no joke. Astronauts can lose their balance and sense of direction, which can cause nausea and confusion. Dealing with that while landing a spacecraft on Mars is definitely not fun or easy. That's just one set of problems. There are plenty of other challenges with a trip this long, like a communication delay of up to 20 minutes one way, the risk of equipment breaking down or medical emergencies, and the constant need to carefully ration food and supplies. Thankfully, the new engine I mentioned earlier might just save the day and could make the trip way shorter, or at least that's what scientists are saying. They've built a prototype of plasma electric rocket engine that could get us to Mars in just 30 to 60 days. And if your first reaction was, a plasma what? Don't worry, I'll explain. So, here's a normal rocket, the kind you see blasting off from Cape Canaveral. It works by pumping liquid hydrogen fuel and liquid oxygen oxidizer into its engine. When the fuel burns, it releases a ton of energy, creating thrust. In simple terms, that burning makes super hot gas that blasts out the back, pushing the rocket forward, and off it goes. Now, here's the plasma rocket. It takes off pretty much the same way using the same chemical mix to launch. But once it reaches orbit, it switches over to an electric propulsion system, and it works completely differently. Instead of burning liquid hydrogen and oxygen, it uses 2 electrodes. When charged particles move between those electrodes and a high voltage is applied, the current creates a magnetic field that pushes the particles out of the engine. That superheated plasma shoots out in one direction, and the spacecraft moves in the other. That's how it creates thrust. We're talking about at least 6 newtons of thrust. To give you an idea, 1 newton is about the same force it takes to hold up a small apple against gravity. Sure, that sounds tiny compared to the explosive power of a normal rocket, but here's the thing. A plasma engine can run non-stop for months, gradually accelerating spacecraft to extremely high speeds. Cool, but how fast are we talking? Well, regular rockets that burn fuel can reach a maximum exhaust velocity of about 2.7 miles per second. Meanwhile, this new plasma rocket can hit around 62 miles per second. At those speeds, a rocket trip to Mars could only take a month. That's a huge difference. That's why people think this new engine could completely change space travel. By letting spacecraft go way farther while using a lot less fuel, this tech might finally be what we need to leave our footprints on the Martian surface. And who knows, maybe even go beyond that. But it's not exactly ready yet. It could take years. Right now, it's more of a prototype, still in a very early stage of development. It's being tested inside a special facility, a 46-foot-long vacuum chamber about 13 feet wide that simulates the conditions of space. The whole idea is to see how the engine performs in realistic conditions before actually sending it into orbit. One of the things they might want to test is how it reacts to gamma-ray radiation. Because out in space, radiation isn't just sunlight. It's streams of tiny subatomic particles coming from the Sun, the Milky Way, and even beyond. They may be small, but they're still a major challenge for long missions. Because here on Earth, radiation from the Sun and space isn't a big deal. Our atmosphere and magnetic field absorb or deflect most of it. But astronauts and their spacecraft don't have that kind of natural protection out there. The problem is that these high-speed particles can pass right through the human body. They can tear through DNA molecules, breaking them apart and causing serious health problems. Even just an hour without proper shielding could be life-threatening for us. Well, for the astronauts, I mean. But it's not just humans. Spaceships take a hit too. These particles can penetrate the spacecraft's materials and damage sensitive electronics, causing glitches, malfunctions, and even complete failure. That's the last thing you want on a long space trip, right? It's not like there's a pit stop with a mechanic on the way to Mars. And with a round trip taking over a year, that's a huge problem. The longer astronauts and their ship are exposed, the higher the risk. That's why finding ways of getting to Mars faster is so important. But the creators of this plasma engine are not the only ones racing to get to Mars with faster rockets, though. NASA recently teamed up with the Defense Advanced Research Projects Agency to test a nuclear thermal rocket engine in space, a technology that could also cut down travel time for future human missions to the Red Planet. Meanwhile, SpaceX has even bigger ambitions with their colonization program, better known as Occupy Mars. Their plan is to send people to actually live on the Red Planet, hoping it'll help humanity survive in the long run. They're planning to launch the first starships there in 2026, but they'll probably still be uncrewed. The scientists are confident that those ships make it to Mars in just 6 months. So, we've got a plasma engine, a nuclear thermal rocket, and a whole Occupy Mars mission all racing to get people to Mars very soon. But who is really going to pull it off first and get there the fastest? I guess only time will tell. But hey, you can drop your guess in the comments.